In this video, we're going to be working on factoring when the pattern of your expression shows a difference of two squares. And so what we mean by that is that you have two different terms. So this is a binomial. And so it's a binomial, so it has two terms, and they each can be written as some value squared. And it must be a difference, so you have to be actually subtracting those. And so if that's the case, then you can quickly factor that into two factors, where it's just going to be a plus b times a minus b, where those a and b are what's going to be squared to give your expression. And I've drawn a generic rectangle to show why a difference of two squares needs to happen, because if that subtraction there allows this piece to be negative, and so the parts in red will cancel out if you actually combine your like terms from this multiplication problem. So a few examples. If you have x squared minus 49, you need to think of the two things that will be squared to give you these parts. So these are each binomials. They have two terms, and they're each going to be squared. So something squared gives you x squared. Well, that would be x. And so you can start your first factor that way. Actually, I'm going to write out parentheses here for each of these. So this gives you x. So I'm going to put an x in both of those parts. And you know one's going to be a positive and one's going to be a negative. That's very important, one positive and one negative. And you think, okay, well, what squared gives you 49? And that would be 7. So 7 squared equals 49. So that's why a 7 goes here and a 7 goes there. Same idea for each of these then. Since this is a difference, subtraction, and then you have two different squares here, you can write this as the quantity where one's going to be plus and one's going to be minus. The very first thing, so you say, all right, well, what squares gives you 4x squared? And that would be the quantity 2x. So 2x quantity squared gives you 4x squared. And then in the other part, it would be 3, because 3 squared is 9, so plus 3 and a minus 3. That would be that factored version. Getting to slightly more complicated problems, here we do have a difference as well. And you say, okay, is something squared x squared z squared? And is something squared 36y squared? Yes. And so as you write those out, you're going to have a plus and a minus here. So what squared is x squared z squared? Well, that would just be xz, the quantity, squared. So I have to put an xz and an xz. And then what squared is 36y squared? Well, that would be just 6y. And so that quantity is what's squared. So 6y. Oh, and I made that wrong. This is supposed to be a minus sign. I apologize. And then this would be a minus 6y. And for this one, question 4, we have a greatest common factor of 3y out front. That's going to stay there. So you have a 3y out front. This is a difference of two squares. So you put two parentheses there, one plus and one minus. And then again, so x squared, that's just going to be an x quantity squared. And then for 25, that is 5 squared, so plus 5 and minus 5. That would be your completed version there. Now, a couple bonus problems would be, what if you had x squared plus 9? Well, x quantity squared is going to be a square number. 3 squared is 9, so that works too, but this is a positive, and so that doesn't work in your difference of two squares method, so this can't be factorable. So we call it non-factorable. And so you would not be able to factor that. You could still solve stuff, just not factor. Bonus question 2 is, what if you had x squared minus 15? So here I have a binomial, so two terms, and you're subtracting, so that's good, but now 15 is not a square number. So we don't tend to write this out as a factored version, but I mean, technically you could if you were just to write out what your square number or square root is. So this would still be an x and an x, and you could say, well, square root of 15 quantity squared would get you 15, and so you could put the square root of 15 in each of these spots. We don't usually do that a lot or ever, but it is something that you could do if a problem asked you to do it at a certain time, or if you had to use it for a simplification problem. So just kind of an extra bonus there. Thank you. Good luck.